I think our fundamental limitation is that we haven't really taken advantage of multi-scale competency. And so in biology, and we're just now starting to, I think, really get a handle on this. The thing about biology is that every level of organization, from chemical pathways to cells to tissues and so on, all the way up, every layer has its own agenda. They are not passive materials. They are what we call agential materials with an agenda, with certain competencies in various spaces. They all work in diverse problem spaces. They all have different degrees of ability to solve problems and different preferences and memories and so on. And so uh, that means that engineering with these kinds of agential materials is completely different. So just as kind of a dumb example, if you're going to build a tower out of Legos, right? What you know is that all the Legos know how to do is keep their shape. That's it. And so everything's on you. Building it, everything's on you. And this is to build it, to put them wherever they go. This has been how we've been engineering for millennia. That's how we engineer with wood and metal and everything else. If you want to build a tower out of dogs, you can't use that strategy, because if you stack them on top of each other, they'll run away. It doesn't work. However, what you can do is you can train the dogs, right? And if you train the dogs, you can have a nice tower. And the cool thing about that tower is that if you knock it over, it'll build itself back up, because it'll get right back up. And so as an engineer, what you realize is that you have a different type of material. You're dealing with an agential material. You have a completely different set of tools that you need to use. They're not tools of physics, they're tools from behavioral science. And instead of placing things, instead of micromanaging things, what you're doing is taking advantage of this amazing native competency of these beings to learn from experience and to be behavior shaped. We don't have a good science of estimating and what kind of intelligence is going to be formed from a collection of parts that we do understand. What are going to be the competencies of that intelligence? What are going to be the goals of that intelligence? How are we going to recognize it? How are we going to relate to it? We're still not very good at that, and I think that's what limits the applications in biomedicine, but also in engineering of all kinds, because we really need more frameworks for detecting and starting to take advantage of the native competencies of the things that can be built, and with using materials beyond passive matter, active matter, that these agential materials. That I think is going to be transformative for both engineering and biomedicine. Yeah, well, let's take a step back. One thing that I think is really important is not to have binary definitions for any of these things. So I don't like the question of whether it can be sentient. I think for almost anything, for any of these terms that we're interested in, so intelligence, cognition, and so on, the way to do it is to talk about what kind and how much. I think that's much more useful than trying to make binary categories out of it. And in particular, the thing about these definitions, and people argue about this stuff all the time. They use these words and argue about whether certain systems have it or not. The real question is, what do you expect that word to do for you, right? So for all this terminology, I mean, I'm less interested in kind of philosophical debates about language meaning, and more like what do you want the word to do for you. So I don't use the word sentience much. I have a thing that I call a spectrum of cognition, and we can have particular sort of waypoints on this spectrum that are, the reason they exist is because when you are in the vicinity of a certain position on that spectrum, that means there's a certain set of tools that someone might use to interact with that system. So you could go from mechanical clocks to things like thermostats to certain simple creatures that can have learning and memory, and all the way up and up in each of those things. So I don't know. I'm not sure there's a super useful notion of an additional concept of sentience. To me, it has something to do with a certain kind of depth and sensitivity to the environment and context specific action, which I don't think it has specifically anything to do with humans. I don't even think it necessarily has anything to do with life forms. So could some AI be sentient in that sense? Yes, of course, absolutely, I think it could. But the real question is, what do you want, what work do you want that word to do for you?
And what kind of work you assume, like if you think about it, what could be, yeah, possibilities in that case?
Yeah, I like a kind of expanded view of engineering. So to me, engineering is about relationships fundamentally. What kind of relationship can you have with a system? So for very simple systems, you're talking about prediction and control, and you want to make them do specific things. And then as systems get more and more complicated, and you get into, at least at this point, what are largely complex living systems, you get into other kinds of relationships where you're doing behavior shaping, and eventually you're dealing with something so high in its in agency that you're actually benefiting from interacting with that agency. You're not trying to get it to do anything. You're having more of a peer to peer kind of relationship, right? And this is what a lot of the discussions nowadays are like. Is, as humans are going to have various interactions with unconventional intelligent systems, whether that be software, whether that be new biological kinds of synthetic beings, whether hybrid humans that have different kinds of implants and whatnot. The real question is what level of relationship are you going to have? Is it and there are many possible ones, ranging from what we do with kind of simple machines to animals to other humans and our spouses, and possibly greater intelligences. What kind of a relationship would you have with an intelligence that was significantly greater than yours? There are many options, but I think they're all on the same spectrum. I think they're all on the same spectrum.
But currently speaking, I'm just curious because I think you mentioned other podcasts, like other form of intelligence, like aliens or other species. How do you see the relationship that if we understand like modeling for how we interact with more advanced intelligent, or yeah, this kind of example? How do you see this relationship here, or if there is an example
Yeah,
already?
well, I think that, yeah, I think that all the troubles we're having and the debates around AI are a kind of a practice run for a much bigger and more important set of questions, which is how do we relate to other minds in general, other unconventional intelligences. So for a very long time, we've gotten as a species very complacent because all of our relationships have been with other creatures on our single N of one tree of life here on Earth. So we're pretty used to looking at things and kind of deciding where on that tree of life they go. And depending on whether you're a fish or a mammal or a single cell or a human or something else, we've kind of developed plus or minus consistent ways of relating to those things. But we really, I think, to mature as a species, I think we really have to get much better at figuring out ethical and rich and fruitful ways to relate to other unconventional kinds of minds that are nowhere on that tree. And that may be because they evolved somewhere else, or they were engineered, or some combination thereof. They might be software, they might be synthetic biologicals, they might be hybrids or hybrids or cyborgs or whatever they're going to be. There's this massive space of possible other beings, and we simply cannot continue the old way of figuring out how we're going to relate to each other based on what do you look like and how did you get here, meaning engineered or evolved. I think these are terrible categories. So we're going to have to develop better ways. And I think fundamentally, uh, people sometimes wonder, like, okay, as humans become further modified, I mean, we're already modified, but let's say we get more modified in both in biological and technological ways. What is the essential human, right? Like what at what point are you no longer human? People sometimes ask. Another way to look at it is, especially with the AI debates, people are interested in what they call proof of humanity certificates. I've heard, I don't know who, but somebody is working on this kind of thing, where you want to be sure that the being you're interacting with, or some kind of work product, came from somewhere, that there was a human on the other end. So okay, so let's say we're going to have these proof of humanity certificates. If we're going to have some sort of a relationship, uh, what is it that you would really like to know to make sure that someone is worthy of a human style relationship? Is it the DNA? Do you want to know that they have human DNA? I don't think so. I'm not interested in anybody's DNA really for that purpose anyway. Is it the anatomy? You want to make sure that they still have kind of a standard human anatomical structure and not too many replacement parts. I don't really care about that either. I don't think too many people fundamentally do. So what is it? So I think what we're really after in terms of proof of humanity, first of all, is a minimal cognitive light cone that says that this other creature is able to care about the same size of goals that you can, roughly, right? Not too much smaller and maybe not too much larger, but having a compatible, almost like an impedance match, if they can care about the same level of things that you can care about. I think we are really interested in the level of compassion that they can muster. We want to make sure that they are capable of that same kind of, and ideally larger, but at least that same kind of human level of compassion. And I think that we're also interested in uh, having relationships with beings that have some of the same existential battles that we do. You know, we are a self-composed, limited being with a finite lifespan, with many fundamental questions about what we should do and you know what we really are and all of that. And I think it would be very hard to have that same kind of relationship with a creature that didn't have any of those concerns. And we can there are many details that we could delve into, but I think those are the kinds of things, you know, those are the things that you want to have. It's more of a, I don't know, you could call it more of a spiritual connection, but it's definitely not about what you're made of or what your DNA is or anything like that.
Be quickly, since you mentioned the finite time span here for our life, if we have a machine that maybe in the future machine that already sentient, and do you think there's, if a machine doesn't really have to die or anything like that, so how do you see that, if happened that we have this component but it doesn't have this limitation as we had?
Hmm. Yeah, well, and by the way, I also think that someday we won't have that limitation either. You know, I think at some point we are not going to be susceptible to aging the way we are now. But let's say in the meantime, while we still are, yeah, I think it's difficult having a peer relationship with someone who doesn't understand and cannot understand your one of your fundamental struggles, right? The fact that we are only here for a short period of time uh, implies all kinds of interesting things about our psychology and the way that we face the world, and just, you know, the way beings exist, the current living beings exist in the world today. And I think it's hard to have, but we'll have a different, it'll just be a different kind of relationship. I'm not saying you can't have one. I'm saying it's not going to be what we typically understand as a basic human level relationship. You know, there are shared assumptions about the kind of fundamental existential struggles that we all go through, that I think underlie our ability to understand each other. But we'll figure it out. I'm sure it's possible to figure out a different kind of relationship.
Can you tell us more about this part? I think it's interesting how it's come. Is it because of the brain or something beyond the brain here, the sentience? And yeah.
Well, again, it depends on what you mean by sentience. You know, if we're talking about memory, so a history, decision making, problem solving, intelligence, all of those kinds of things. Those things, the brains don't have any monopoly on those kinds of things. I mean, what we are used to, humans and some other, you know, mammals and so on, that's how they implement this. But I don't think there's anything fundamentally unique about those things, and I don't see any way that we wouldn't be able to reproduce some of those key functions in other media, right? It seems completely impossible to me that in the whole universe there's only one way of doing the kind of let's use your word sentience, and that's what we have. Though that's this kind of brain, right? I mean, that seems completely implausible to me. So I think the things that are important about agency and about intelligence and about all the cognitive things that make us interesting, I'm pretty convinced that there are multiple ways to implement that, and it's not necessarily about the brain at all.
Hmm. So when we mentioned the reality, also one of the conversation you had about the reality, and I'm just curious about, since we don't have access to the full reality of the thing, is it because of limitation sensing or what exactly that we don't know the reality of things around us?
Yeah. Um, well, I think that fundamentally, if you imagine how we come into the world, so we're a collection of cells, and this collection of cells has certain stimuli that come at it in different modalities, and it's able to sense some range of things. Some pieces of the electromagnetic spectrum, and some chemical, some regions of chemical space, and some touch and some other things like that. Um, and then what you're going to have to do is you're going to have to make some kind of a model about what all of that signal, what all those signals mean. And so all living things, and increasingly so non-living things, are going to be making models of what do all these stimuli actually entail about the outside world, and that's all that they are. They're models. And so there's absolutely no way that I can see that we have at least through our physicality have direct access to the physical reality of space. We may possibly have some access to things like truths of mathematics and so on, but as far as the space that we're in, and these are physiological spaces, and of course 3-dimensional space, but also morphological spaces and so on. We don't have any direct access to any of that. We take measurements and we try to cobble together the most efficient model that we can, and that model is limited by the our own structure and our capacity to make models in the first place, right? So our basically inherent IQ for making models of our world and of ourselves, and then of course the actual signals that we're getting, which are limited, and of course then also limitations of time and computation. So we don't have all the time in the world, and we can't do all the computations that we might want to do on these inputs. So given all those realistic constraints, our perceptual and control system cobbles together the best possible set of interpretations that it can of what's out there. There's no way that you could say that that's real in any sense, or that you know there's just all it is cobbling together a model from the data that you have.
Interesting. But I'm curious also if there is a purpose for that. If you, because I think maybe from philosophical point of view, if there is a purpose that sometimes we don't have the full picture, what is the reality of things, or you don't believe in if there's a purpose for that.
Yeah, that's a deep question. I think that I think purpose is always relative to some observer. So purpose is relative to some creature who, or some agent who's, it doesn't have to be biological, but it's some agent that's going to try to implement that purpose. And so I think the world is full of purpose. I think there's purpose everywhere because it's full of agents that make their own purpose, and we are agents that make our own purpose. And so, is there is there some other agent that specifically crafted us with a limited perception? I don't believe that. No, but are we able to make real purpose in our life? Yes, I think we absolutely can.
And also in the paper you mentioned about I think that's also discussed about bullet computing. And I think that's very interesting. I feel that's had a relation with this concept. And also curious if you can also
Yeah.
break the bullet computing here part because it's an interesting part here.
Yeah. I mean, the notion of polycomputing, kind of the very simple and sort of more computer science aspect of it, is the kind of work that, for example, Josh Bongard does, where what they've shown is that you can take the same set of events and interpret it as different computations. And so in biology, this happens all the time. Biology proliferates observers everywhere. So there are at every cell, every set of molecular interactions, every tissue, organ, and on the way up. All of these are various observers who do their best in interpreting things they see. And the central insight of polycomputing is that there is no fundamental, objective, true ground truth as to what is being computed. It's up to the observers to decide what they think is being computed. Now, that doesn't mean that anything goes, because some interpretations are way worse than others. In fact, most interpretations are bad, and then some are pretty good in enabling you to have adaptive, fruitful, and rich interactions with that system. So there are better frames and worse frames in that sense. They're not all equal, but there isn't one true true unique one. It's on the observer to interpret a set of physical events as some kind of memory, as some memory trace, as some kind of computation, as how do they want to interpret this. And so that's the basic notion of polycomputing, and that's I mean, you're right, that links tightly to what I was just saying about purpose, which is that um, multiple observers will have different views of the purpose they create, and also the purpose they detect in others. So when you see some creature doing something, and we can have debates about, is it doing it on purpose, or what was the purpose? The way to settle those debates is for everybody to make hypotheses about what problem space they're working in, what is the goal they think this system is trying to reach, and what competencies they think it has to reach that goal. Then we can do experiments, perturbative experiments, to find out which of those frames gives the better way to the most efficient way to relate to that system, and then we can rank them and say, okay, well, this one is better than this one is better than that one. But that's a very different view than thinking that, okay, there's one actual computation that's being done here, and then we can sort of decide which one that is.
Maybe I'm curious about what's your view about general artificial intelligence. Do you think that if we speak about them, especially in the machines, that do you think we can reach this level? Thanks. I don't know if you see the Jeffrey Hinton interview. He was talking about the risks, and he was just, yeah, concerned about the current advance. And I
Yeah.
curious, what your view? Do you think there's just hype a little bit, or there is a true element of what he concerned about?
Yeah, well, I would divide it up this way. Let me kind of carve up that question a little bit, and then I'll just say some comments on different parts of it. I think people tend to conflate a number of different areas that I think have to be dealt with separately. So the first question is, whenever we talk about these things, are we talking about today's state of the art, or are we talking about in principle? Because that's really important, right? It's perfectly possible to say that today's state of the art does or doesn't do X, Y, Z, but that doesn't mean that this is a limitation on all machines. And so a lot of times when people say it can't do this or it can't do that, we need to be very clear. Are you saying that this type of approach is never going to do it, or are you saying that today's versions do or don't do it? So I want to be kind of clear about that. The other thing to really get clear about is this aspect of the danger of it. There are many dangerous things that are, never mind human level intelligence, they're just very low intelligence, and they're still incredibly dangerous. So I don't put those two things together necessarily. I think that it's very easy to create something that is going to be highly dangerous, not because it itself is so intelligent, but because of the way that humans are going to interact with it. And so I think those are completely separate questions. How dangerous any technology is, and whether or not this thing is going to reach some sort of human or above intelligence, those are both good questions, but they're very different questions, right? You don't have to have general intelligence to really wreck society, because we're very good at breaking things ourselves for not very good reasons. So I think those are separate questions. I think also that what's important here is that I think in general, the one thing missing from a lot of these debates, and obviously there are some very smart people who talk about this stuff and way, sort of more experienced and so on than I am in this area. So the one thing that I think is missing from all of this is really a consideration of the field of diverse intelligence, because people are really hyper focused on humans and human intelligence. And I think it's really clear that you don't need to be a human mind to be interesting, to be intelligent, to be morally important, to be worth consideration, to be dangerous, to be positive, to have positive influences. None of that requires you to be human. In fact, it doesn't even require you to be similar to the kinds of things that we're used to on the tree of life. There are very diverse intelligences. So when people argue all the time, oh, this thing isn't human, humans do it differently. I mean, that's fine, but there are many different kinds of minds, from slime molds on up and then sideways into things we've never seen before. So I really think this hyper focus on being human is mistaken. I think we have to understand that there are many other, and the reason it's surprising is because it used to be that the only things in our environment that could talk were things that were actually like us, and we got used to that. Everybody's used to that, and so now we're breaking that. We have things that can talk, and they're not like us at all in many ways. Although in some ways they're more like us than we think. Um, but this is what's creating a lot of the problems, and uh, it's due to a lack of appreciation of this broader area of diverse intelligence. And I guess one other thing that I want to kind of talk about is this, that I think, okay, I think of course it's true that with the arrival of AI, even of the kind that we have now, there are going to be unique situations and unique problems we haven't faced before. I'm sure that's true. However, I really think it's interesting and important to focus on the ways in which all it's doing is holding up a mirror to things that have already been here and been fundamental problems all along. And it's just that most people don't make them explicit, right? Although philosophers, of course, have been worried about this for a long time. So I'll just run down a few, right? So one of the things that people worry about is that we are actively making a high level intelligence that we're not going to be able to control. Okay, true. we've been doing this for millennia. It's called having children. When we have kids, we already do this. We make high level, guaranteed high level intelligences, which we do not control. We do our best, and some of them go on to do amazing things, and some of them go on to do terrible things, and we have very limited control actually of how that's going to turn out. And this has been a problem with us forever. People say, what if the general AIs of the future don't share our values? What if they don't think we are important, or the things that we think are important? Yeah, again, same thing. We have kids, and we all, as a society, worry about, are the future generations going to have the same consideration of, that the things that we care about are really important, or are they going to have new values? And what happens when values change? I mean, that's scary, and that's been with us forever. This whole issue of how hard it is to regulate this field, and we have no idea. Anybody is going to be able to make these things, and train them on different data, and this, right. And this is, again, you have no control over how your neighbor's raising their kids, and how some other societies raising their kids. You have no control over that. So this is a fundamental problem. All of these things are unsolved issues. The issue of them maybe supplanting us, and being basically better than us at doing various things. Well, it's always been true that no matter what, I don't know about anybody else, but for me, every single thing I do, somebody in the world is way better than me at doing it. And so if I was going to get upset and not want to do things because somebody somewhere is way better, that's a terrible way to go through life. You can't only do things because you think you're the best at it. And I think we have to get past that, and have to get past this idea that the things that we're interested in are going to lose their value because there will be some other system out there that's better at it. People also say, well, these AIs. I mean, somebody said once, it's just linear algebra. It's well, right, and we are just ordinary differential equations. We're made of stuff, and that also has been that's bothered a lot of people. This idea that we can actually look into the material of which we're made and really just see chemistry and physics. That's all you really see when you zoom in. Not that you have to zoom in. I think that's another problem is people zoom in too much. But if you do, on the one hand, you see electrons and matrix algebra. On the other hand, you see potassium ions and ordinary differential equations, and that's been problematic. People have found it for millennia hard to understand how you can reconcile, right, our feeling of agency and moral worth and all that with the fact that, yeah, we're just made out of stuff too. So those kinds of things, the issues with misinformation, right, and the fact that these AIs generate all kinds of crazy. Well, so do people. I mean, when you go online, I mean, there's a lot of liars and a lot of bad actors, and that's been the case forever. The fact that you can't just trust things people tell you, that's a fundamentally unsolved problem too for us, long before AI. You know, those kind of issues. The fact that here's another thing, that they take on personas, right? So they say, oh, it doesn't have a personality of its own; it just sort of takes on personas. Well, we actually have this issue too. There are dissociative states, there are split brain patients, right? We know that there are components of our minds that are not as unified as we think, and that's disturbing. And we've known that for some decades, and that's really disturbing. So in all of those ways, these issues with alignment, all they're showing us is that we aren't aligned with each other, with ourselves. There are societies that are absolutely not aligned on fundamental values and things like that. So it's a lot of this kind of stuff. There's way more, but I think in many ways the things that people worry about with these AIs, they're really just amplifying, so that now the average person can see that these issues are profound. But these issues have been with us all along. They're not new with AI, most of them.
Hmm. I really liked every point you said. It make a lot of sense. I appreciate that. So maybe I want to maybe ask you, since we speak about machine, and I think we speak in the past about bots and how using biology was maybe be I don't know, like hypothetically after cyborg or part of artificial and biology, and specifically about artificial muscles. Like, I'm curious about this part because I think even in robotics, but I know we don't speak about robotics here, but in general, if we want to create something like what we have in, like artificial muscles or something resemble what we have in evolution, but with advanced intelligence. How we can do that to merge something, building something like that? What does it take to build something strong like muscles and that we have, and also intelligence? So is it hard to do kind of machine like that, or still we have limitation?
I think that our biggest limitation, I mean, then there's certainly people doing amazing work in hybrid robotics and soft body robotics and so on, things like this. I mean, there are many people who work in this field, but I think our fundamental limitation is that we haven't really taken advantage of multi-scale competency. And so in biology, and we're just now starting to, I think, really get a handle on this. The thing about biology is that every level of organization, from chemical pathways to cells to tissues and so on, all the way up, every layer has its own agenda. They are not passive materials. They are what we call agential materials with an agenda, with certain competencies in various spaces. They all work in diverse problem spaces. They all have different degrees of ability to solve problems and different preferences and memories and so on. And so uh, that means that engineering with these kinds of agential materials is completely different. So, just as kind of a dumb example, if you're going to build a tower out of Legos, right? What you know is that all the Legos know how to do is keep their shape. That's it. And so everything's on you. Building it, everything's on you. And this is to build it, to put them wherever they go. This has been how we've been engineering for millennia. That's how we engineer with wood and metal and everything else. If you want to build a tower out of dogs, you can't use that strategy, because if you stack them on top of each other, they'll run away. It doesn't work. However, what you can do is you can train the dogs, right? And if you train the dogs, you can have a nice tower. And the cool thing about that tower is that if you knock it over, it'll build itself back up because it'll get right back up. And so, as an engineer, what you realize is that you have a different type of material. You're dealing with an agential material. You have a completely different set of tools that you need to use. They're not tools of physics, they're tools from behavioral science. And instead of placing things, instead of micromanaging things, what you're doing is taking advantage of this amazing native competency of these beings to learn from experience and to be behavior shaped in a way, right? And so and this is true. So I've argued that this is how biomedicine has to be transformed. That we've been treating all our cells and tissues as if they were mechanical clocks, meaning bottom up rewiring, protein engineering, genomic editing, that kind of stuff. And I think what's really just not even begun to really be exploited very much is communicating with them top down to reset their set points, to take advantage of their native competencies and native intelligence. And we've done a number of these things in our lab, and so have other people. And so I think that what stands in the way of all of this is that we're still really not very good at, we don't have a good science of estimating and what kind of intelligence is going to be formed from a collection of parts that we do understand. What are going to be the competencies of that intelligence? What are going to be the goals of that intelligence? How are we going to recognize it? How are we going to relate to it? We're still not very good at that, and I think that's what limits the applications in biomedicine, but also in engineering of all kinds, because we really need more frameworks for detecting and starting to take advantage of the native competencies of the things that can be built, and with using materials beyond passive matter, active matter, these agential materials. That I think is going to be transformative for both engineering and biomedicine.
Interesting. I'm also curious what else other things you're still trying to understand, or other questions in this building with the machines, or take advantage of that. Do you think there's still like questions or things just still you so bother to know how the things work or how to take advantage of the system? I'm just curious, what is in your mind about these things?
Yeah, I mean, we know almost nothing about this. When we create collective intelligences all the time, both in the laboratory, in the social structures, financial structures. We make these things all the time. We don't yet have a good science of understanding what their capabilities, what spaces they're going to be working in. I mean, you have, I mean, think of the biology. You have individual cells that have competencies in physiological space and metabolic space and transcriptional space, but you put them together with certain hardware that has to do with multicellularity, and suddenly they're solving problems in anatomical morphospace, and they're using bioelectric signals to navigate this amazing anatomical space of possibilities. And then you speed up some of those evolution speeds up some of those processes, and you have now you have now they're solving problems in three-dimensional space, and eventually by moving, and and eventually linguistic space, and who knows what else. So our ability to recognize that kind of stuff is quite poor still, and that's, to me, that's one of the most exciting things going forward. I think the field of diverse intelligence is one of the most exciting fields, because there you're really asking the very fundamental question of what is it, what do all cognitive agents have in common, and how can we recognize them? And this isn't just for exobiology, when we find some alien life or something. This is going to be critical to our survival as a species here, because all of these collective intelligences are, first of all, already being made, and second, we really need to our survival and our optimization of where we are today, which is really not very good, right? We face many problems of environment, or we face personal limitations. We're susceptible to all kinds of ridiculous diseases and aging and degenerative processes and all of that. I mean, all that's got to go, and the only way we're going to get past all of that and improve this kind of suboptimal status that evolution has dropped us in, is by really understanding how collective intelligence works. That's the future.
But I'm curious how you keep this every day, keep yourself updated to these old interests, different interests in your life. I'm just curious. It's something. Yeah, I think honestly, for me, well, aging, I have fear of aging, and how you keep yourself just a young mind and up to date everything. How you keep up with all these things. I'm just curious. Yeah.
Yeah, I wish I had some sort of magic solution. I don't, and I certainly don't feel up to date. I have, you can't see it, but in front is so those are books from the past. But there's a in front there's a huge pile of things that I haven't read yet, and all the paper never. I mean, all the papers. I mean, like, it's just the amount of material is incredible, and I mean, really good. I'm not talking about the junk. I'm talking about really good stuff from people who, they're putting out gold, right? And it's and they're and these big fat papers with really important things. Um, I'm not sure it's possible to keep up with all of it. I think that to a large extent, and I think about this too with my own writing. I mean, we all sweat and bleed and spend time and write these big things, and then you wonder who's going to read who has time to read all this stuff. Who's got time to read my papers? I don't know. And so one thing that I sometimes think is that we're not really writing it for each other. Really, we're writing it for future intelligences, and they may be biological, they may be digital, they probably will be hybrid, whoever they are. But I can only, and this is maybe just trying to squeeze some optimism out of this, I think in the future there will be beings with significantly larger cognitive light cones that can actually benefit from all this stuff. So nowadays, when I write, I don't think that it's today's. I mean, okay, some of my colleagues will read it today, but fundamentally, I think that this is for the future, because we are. I mean, we're all. I think all the other academics can also agree with us that keeping up with everybody is almost impossible for us. Um, so I hope, hopefully there will be better. We will have larger cognitive capacity in the future, that we can actually do all that. But and maybe it'll be the same problem that with that will come that all the intelligences of the future will also write 10 times more papers, and so they will have trouble keeping up too. I don't know, I don't know, but for me, I try to prioritize. I try to keep up with the most important things. I have some amazing collaborators, and I sort of count on them to um, really synthesize fields that I'm not an expert in. So I'm not going to try to be an expert in physics, because I've got, let's say, Chris Fields, and I can talk to him, and we can pull out what we need together. But for the fields that I do primary work on, Yeah, I do my best. I try to keep up with the most important stuff, but it's a losing proposition. I think you can't. I mean, there's no way to do it. There's no way to keep up.
Yeah. Maybe I want to ask you what makes you afraid, something fear, I don't know, in life or general. Do
Hmm.
still biggest fears? Do you have any fears or?
Yeah, yeah. I mean, well, a couple of things. I guess the most useful thing to say about it is that people often ask me that in the context of some kind of scientific ethics. So they'll say, what are you afraid of in terms of the work that you're doing? And there's two ways that they can go, and I think most people are thinking of some kind of unexpected consequence of your research, and that can certainly happen. I mean, the guy who came up with Freon and leaded gasoline, he's just trying to save people from being blown up in their kitchens and in their cars, right? And yet look, the effects that has had on all of us. So it is certainly possible to have negative outcomes, but I actually I'm not afraid of that very much. I think what really keeps me up at night is the possibility, the very real possibility that we, meaning myself, my lab, other, the whole community, I don't just mean me, but all of us, are going to fail to live up to the possibility of what we could be doing. In other words, that we are not going to push these technologies and these concepts to the point where they can actually improve the lived experience for everybody. I mean, I'm not kidding when I say these things. This is long term stuff, of course, not tomorrow, but I take it seriously. I believe in radical freedom of embodiment. I think that everybody should have the structure and the cognitive apparatus that they want. I think at some point in the future, you will have whatever kind of body you have. You will have whatever kind of IQ you want to land on. Uh, I think this is important. I think that where we are today is not some sort of highly curated natural state that's sort of best for us, and this is the level of IQ and disease susceptibility we were supposed to have. I don't believe that for a moment. I think this is where random evolution has dumped us, and now we can do better, and I think we have the moral responsibility to do better for everybody. I'm not even a clinician, and the emails and the phone calls I get every day from people with the most unbelievable, suffering and medical circumstances and everything else, uh, that's what keeps me up at night, is that we simply will not be able to push forward enough to help everybody who needs it. That's what I'm afraid of.
I can't agree more with that. Maybe when you say different bodies and IQ, what do you mean about that? Because I'm just trying to imagine what you mean with different bodies and different IQs.
Well, two. We need two concepts for this. One is oftentimes people use this word natural, which I think is a very very bad term, and what they mean is that there's some sort of optimum level, and they, for some reason, they've decided that today's humans are somehow at this optimal level, and that moving off of that level is in some way bad or dangerous. And I just want to point out that nobody optimized this for this. Our lifespan, our current range of IQs, our current level of ability to understand the world, our susceptibilities to bizarre, disease states, and all of the crazy things, that all the crazy medical stuff that happens to people. Nobody optimizes this. Evolution doesn't optimize for our intelligence or for our happiness or for our being able to reach our potential. This is just where we happen to be right now after a lot of combinations of chance and necessity. Basically, we can do better than this. We can do better than chance and necessity. And I think we have to. And so what I envision is that if we truly crack the problem of collective intelligence of morphogenesis, meaning that if we really understood how to communicate goals to cells, such as, you're going to build a heart, you're going to build a limb, you're going to build, if we really crack that problem, we would be able to build whatever you want. And so we would have complete control over biological form. And so that means fixing birth defects, regenerating damaged organs, reprogramming cancer, all of that stuff. But going beyond that and saying, okay, but I don't want my natural level of whatever. That's how I was born. But those are just the vagaries of genetics and environment. And I'm just lucky that some cosmic ray didn't knock out some important machinery when I was an embryo. I mean, that's just chance. I'm not leaving this up to chance. I would like I don't know, you want a third hemisphere in your brain, you want some more eyes, you want tentacles, you want to live on the bottom of the ocean. All of this should be fundamentally possible. I really think so. I know it sounds like science fiction, but I don't see any reason why any of that would be impossible.
It's very interesting because I think it's maybe I was yesterday I was thinking about the fitness of human. Why would we have physio, for example, or fitness for environment? But these are very interesting. What you say now, and how do you anticipate how many years do you think we can reach this? Like,
Yeah, boy, that's tough. Everybody asks that. Look, I don't have a if I gave you a precise kind of time span, I'd be lying. There's no way, there's no way to anticipate exactly when. But um, I don't think we're talking about hundreds of years. I think we're talking about some number of decades, a small number of decades probably, before fundamental aspects of this problem of collective intelligence is cracked. And at that point, the applications will bloom like just in an unimaginable way. I think, and by the way, I think AI will really help with that. I think using artificial intelligence to, well, let's think. I mean, there's the kind of conventional sense in which we can use AI tools for discovery and for data analysis. I'm not talking about that. I'm talking about something a little weirder, which is that I have a feeling that there's this quote that says when what you have is a hammer, everything looks like a nail. And I think what that gets at is the tools that you're using to investigate the world determine what you're going to see. So if you have low agency tools such as the rulers and magnetometers and things like that, all you're going to see is low agency stuff. This is why chemists and physicists see chemistry and physics. They don't see mind, they see chemistry and physics. And that's because they're using tools to interact with the world that are themselves low agency. So I think you need a kind of impedance match of what you're looking for with the tools that you're using to look for it. And we have brains that we can use to recognize intelligence behavior. We're not very good at it in most spaces, but we can do it a little bit. And I think that what AI could do for us is to serve as a kind of uh, agency detector almost. We actually are working on some of this actually in our lab, is to produce a tool that would be good at detecting other unconventional intelligences and that would help us with this. So relating and behavior shaping and controlling depending on the level of this intelligence. Um, I think that once we have something like this, the world is going to look completely different to us. I think there's a huge amount of agency and sentience all around us that we're not very good at recognizing. And once we have tools that can help us do this, our ability to practically relate to all of these things is going to skyrocket. And at that point, we are going to be able to communicate with collections of cells and ecosystems and many other things. That I think is the true promise of AI, is that it's going to open us up to a much more expansive and efficient interaction with the unconventional minds that are all around us.
that's very interesting. Maybe I want to follow up about the different bodies and IQs. Do you think if imagining that we have that, do you think it would be cause like imbalance in life? I'm just curious if for example, you said tentacle and living in an ocean, for example. Do you think interacting with other species? I'm just imagining this scenario. Do you think this is something could be cause imbalance? Maybe I'm wrong, but I'm just curious that if that's happened or I'm just thinking in a different
Well,
way.
so I'm not sure what kind of imbalance you mean, but to be clear, I think we've already caused every kind of imbalance we could possibly cause, right? So we already have a huge disparities in individuals, both in innate and cultural. Um, I think that we have major ecological issues. We already have imbalance, and so now the question is, how do we get better into balance? And I think, and I know not everybody shares this view, but I think the answer is always more science, better understanding, more recognition of mind, not less, not down, no teleophobia and sort of mechanistic reductionism. Recognizing mind, focusing on expansion of our cognitive light cones towards compassion. I mean, we've done some work on this with our colleagues. that's always the answer. It's never less science. It's more. That's the way to fix all this stuff.
Very inspiring. Maybe the final question for you: what kind of truths you still want to find in your lifetime? I'm just curious. Something, since you say stay up late and just being concerned about what you mentioned, but what kind of truth? One truth that you want really to know in your lifetime?
Yeah. I mean, I would like enough of an understanding of, um, just to pick, kind of one thing. I would like to be able to communicate with the collective intelligence of somatic cells enough to be able to actually improve the lived experience for patients. That's what I would like to do. And we've done bits and pieces of it, and parts of our regenerative medicine program are, sort of slowly inching their way in towards the clinic. But I would like to see in my lifetime the beginnings of what I call an anatomical compiler. This idea that you should be able to top down, you should be able to decide what kind of shape and function you want. And we should be able to compile down to a set of stimuli that would have to be given to cells to get them to build that. I want to see at least, I don't know if I'll see the whole thing, but I want to at least see the beginnings of it. And because then I'll know that after that, we're really on our way to, kind of the most fundamental freedom of all. If you come into this world and the limitations of your body and mind that are basically the consequences of the vagaries of genetics and environment and cosmic rays and whatever else. That's just how you get dumped into this world. But you should have options for improvement. And once you have options for improvement, then your agency really takes off, because then you can actually be responsible for what you do next. It's very hard to be responsible for what you do next when you have all these limitations that were actually not of your doing. That I think is the long term way to rise as a species. And yeah, that's what I would like to see.
Wonderful. Thank you. It was really inspiring. I don't know if you have any final words to like say here. Any final words for people listening, if you want to say.
Final words. Well, all I can say is that I think in the topic of AI and all of that, I think what everybody needs to do is pay more attention to the issue of diverse intelligence, to the work that's being developed around increasing systems for compassion, and there are a number of frameworks that are being developed for that. And I think I think if we keep our eye on that, we're going to be much better off.